Hi, my name is Zuliang Weng. I'm doing this demo for classification competition on behalf of Team Commonwealth. We have three members, myself, Liping Xie, and Zijing Chen. For this competition, we picked a language model called BERT. It's developed by Google, and it has been performing very well in all kinds of NLP tasks since its release in 2018. And one benefit for us is that it comes with these pre-trained models, so we don't have to spend a lot of time and resources training the model from scratch. Another tool we use is something called Colab. It's provided by Google as well. It's integrated development environment, so you can write your Python code here and it will execute. So there are many benefits with this tool. It has this consistent environment, so we don't have to worry about the environment difference between teammates. And it also gives you free hardwares that you can use. And it's very easy to share the notebooks between team members. But you do need a Google account to be able to run the notebooks. Since everybody have a Google account, I don't think that's a problem. And also, one thing that we found that sometimes the resource can get messed out, so you have to restart your notebook, especially after you do a lot of trainings with one session. So okay, let's get into the code. So first section is that we asked the Colab to give us a GPU. Here actually we got a GPU Tesla T4. And the second thing is that we want to install the Hugging Face library that we use. So it's down here. Um, Now we are ready to upload our files. We have two files. We have the test and we have the training file. So it's time to upload. Now that files are uploaded, we want to do some conversion here. So because the format is JSON-L, we have to read out files line by line, and then we want to do some cleaning here to basically remove the user token, and then here we load the training data, and then we create a data frame out of those data. So we can actually check out the numbers here. Here we convert the text into numeric values. Okay, now we started to do the tokenization. One thing about BERT is that once you pick the model, you have to use the same tokenizer as that model. So we found the best model we have used so far is this Roberta base, and that's what we're gonna use to tokenize here. Okay, it's done. And then we just print out some sample tokens here just to examine the data. Now, BERT requires token to fit certain formats. It has to have special tokens, and then it has to have a constant length for each sentences. Um, for now, we try to get the maximum length for the sentences, and then we got 106, and then we're going to use that number for padding purpose. So here we tokenize all the sentences and then mark the tokens within their word IDs. Now we started to split our training data into different two sets. One is training data, the other one is the validation. We tried different ratios, but the best one so far is still 9:1 ratio. And here we use a PyTorch data loader to load our data to data sets, and then the batch size is 32. As I mentioned earlier, that BERT comes with pre-trained models, but there are also many other pre-trained models that you can use for different purposes. We found that the best performing ones are the Roberta base and the Roberta base irony. The best one is actually the base, so we're gonna use that as our in our demo. So here we basically load the models and then ask PyTorch to use a GPU. Uh, okay, it's loaded, and then we're gonna print out numbers of parameters in this model. Can I have a take a look? Here we are setting up the optimizer for the training. These are the parameters we use here in this case. We also try other sets of parameters, but so far these are the best ones. This following training loop is largely based the contribution of status backbone. It essentially have two phases, the training phase and the validation phase. And we can detect overfitting by looking at the validation loss. Since these codes are pretty well commented, I won't get into details of this. I will just run that and then show you the output. So it started to trend. Usually the training takes about 10 to 12, 15 minutes based on the parameters you choose. Okay, the training now is complete. Now let's quickly review the training process. Look at the validation loss, accuracy. Let's actually run that, print it out in a table here. We can see that the while training loss is decreasing, the validation loss is increasing. That means we are starting to overfit. Okay. Here we just print out this chart to see the trend of these two losses. Now let's get started with the test data. So let's prepare the test data the same way as we prepare our trend data. So all the codes are pretty similar. We have 1800 test data, and here we actually using the fine-tune model to predict the 1800 test sets. And here we try to convert these numeric values back to text and then generate an answered file that we can use to submit to the competition website. Here we open up the results in a text editor, and then we just quickly go through the results and see if there's any obvious error. We can copy this to the answer the text file and then examine how much difference there is. This is the kit I'm using. So it actually have some differences as the last version. So that's what we're gonna do is to basically check that in and then push the results out. And that's pretty much how the answers are submitted. We use a Google spreadsheet to remember all the factors we used to train the model. And it also helps us to split the workload between team members. And then the best result we get so far gets us to second place. But we are still training, so hopefully in the final leaderboards we can get to the top. That's it. Thanks for watching.